Hi. In the previous video, I defined statistical independence. When can we say two events are statistically independent? And also I said it is very important. The mutual exclusiveness in chapter 1 is frankly, it's not that important. That's just special case. But independence is much more important in general statistics. So I have to discuss how to test independence from the data. So let's think about this. When two events, A and B, are statistically independent, we know they have to satisfy two properties. First, by the definition, the probability of A should not be affected by occurrence of B, right? Unconditional probability of A conditioned on B or conditioned on B complement. B does not happen. They must be the same. This is property 1, and property 2, special multiplication rule. So the intersection, probability of the intersection should equal to the multiplication of two simple probabilities, two probabilities of two events. And then also from these two, we can say that if one of the two condition holds, then we can say A and B are statistically independent. But that's how we test for statistical independence. So again, what I'm saying here is if you can verify this equality, the first equality, then you can say A and B are statistically independent. And if you can verify, the second equality, then also it implies A and B are statistically independent. So you need to verify one of these two properties. And verification is calculating the probabilities. So I will show you how to verify these properties. So method 1 uses this property 1. Property 1 uses this method, and in this property, there are three equalities. Actually, there are three pairs of equalities. First pair, unconditioned and conditional on B, and second pair, B and B complement, and the third pair is unconditional on A and complement of B. But you don't need to prove all three pairs of equalities. What you need to do here is you just need to show one of them, which is very nice. Just show either unconditional probability equals to this conditional probability, or this, or two conditional probabilities are the same. They are, any of these three implies this full equality, right? So it's nice. But what you have to be careful is you have to be careful when you change, when you compare. So A is the main event and B is the condition. But here you are making an error. So B, it should be a condition, and A suddenly becomes a condition. But here A was the main event. So be careful. And in this example, actually we already know that tuition and salary are independent in our example, but let's test it again. We will I will demonstrate how to test it. And in this example, you have to check one of the six equalities, one of these six equalities. The first three equalities use as the salary as main event, right? And then you may choose one of the three, or you may use tuition as the main event. it does not matter. In the end, if one of the equalities is violated, then automatically the other equalities are violated, and vice versa. If one of the equalities holds, then automatically the other equalities should hold. So just choose whatever you want and whatever given to you or whatever most convenient to calculate, and do that. Here is an example. I just chose these two. There is no reason, just I chose these two. You may choose different probabilities. And to test this, simply calculate this probability and calculate that probability and check if they are equal, right? It's simple, as simple as this. So calculate probability of tuition, high tuition. That's simple, this guy's, which is 45%. And calculate conditional probability given S, then conditional on S, the first column, you have this ratio, which is also 45%. Already you verified the equality. That's it. So you may change the equality to any of the others, but I just showed you one example. If they were not equal, then you say they are not independent. Tuition and salary are not independent. This was method 1. Already we verified statistical independence. Alternatively, you may use method 2. So if you have already tested independence using method 1, then you don't need method 2, right? Just you need one of two methods. And the second method is based on the special multiplication rule. So using the fact that statistically independent events satisfy the special multiplication rule. And if this rule is violated, then A and B are not statistically independent, right? It's natural, straightforward. Then what you do here is calculate this guy, calculate this guy, calculate this probability, and multiply those two probabilities of simple events, and then check the equality. That's it, right? So the difference is, main difference from method 1 is that first, you have to calculate 3 probabilities. So it may be more cumbersome. But instead, now you don't need to calculate conditional probability. So there is no conditional probability here. So if your data are given in the form that is more convenient to calculate unconditional probabilities, then method 2 may be more, maybe easier, maybe simpler. So depending on the format of the data or format of the information you have to choose. You may choose method 1 and 2. But in general, not a big deal. Anyhow, back to this example, let's check what's going on. First, I will calculate probability of the intersection, and I will calculate the probability of a simple event for S and probability for T, and multiply them. You have to pay a little bit of attention in this line. When you multiply two probabilities, here I write it as 25% and 45%, but you should not multiply 25 to 45. You have to change them, transform them into decimals or fractions, and multiply without percentage. Otherwise, if you multiply 25 to 45, it must be several hundreds or several thousand. Means nothing. So you will get a decimal, and then in the last step you may change it back to percentage, or itself is a correct answer. 11.111225 is a legitimate probability. Anyhow, finally then compare this guy multiplication with the intersection. They are the same. So those two events are statistically independent, as we already knew. And if they were different, if they were not equal, then they are not statistically independent. Okay, this is the end of excuse me. This is the end of class 4, and as I said, I made a separate video for Excel pivot table, how to calculate conditional probabilities on Excel. And as before, I'm going to upload the slides and the data file on Blackboard, but unfortunately, I could not finish the slides for the second part of this chapter. So I will update the slide when I update the video, the video next in next week. So please understand, and don't forget to do homework 1. Homework 2 will be uploaded soon. So so do not procrastinate, please. Okay, I hope you enjoyed the videos, and let me know if you have any questions. Come see me in the office hours. In the past 2 office hours, no student showed up, which is good for me, but I was wondering how you are doing. So if you have any suggestions, questions, comments, let me know. Shoot me an email, and hope you stay safe. See you later. Bye.